Question 27, Part D. Ted has borrowed $70,000 at an interest rate of 6.24% per annum compounded monthly. The repayments have been set at $680 per month. The loan balance sheet shows the interest charged and the balance owing for the first month. Part 1. Explain why 0.0052 is used to calculate the monthly interest. The interest rate is quoted as 6.24% per annum or per year, compounded monthly. Now we need the monthly interest rate, and there are 12 months in the year. So we need to divide this value here by 12. So the monthly interest rate is equal to 6.24% divided by 12, which equals 0.52%. And converting this value as a decimal by dividing it by 100, that equals 0.0052 as required. Part 2. Find the missing amounts at A and B. The value at A represents the monthly interest that is charged on the principal or the amount owing at the start of the second month. And the amount owing at the start of the second month is $69,684. The value at B represents the balance or the amount owing at the end of the month when the monthly repayment of $680 is taken into account. So the value at A is found by taking $69,684 and we multiply that by the monthly interest rate that we found in part 1, which is 0.0052, and that equals $362.36, correct to the nearest cent. And the value at B is found by taking the principal of $69,684, adding on the interest charged, which is $362.36, and taking away the monthly repayment of $680. And that equals $69,366.36. Part 3. Ted would like to calculate the number of months, N, it will take to repay the loan fully. He uses a guess and check method to estimate N in the following equation. $680 times 1.0052 to the power of N minus 1 all over 0.0052 times 1.0052 to the power of N equals 70,000. Here is his working. Try N equals 200. $680 times 1.0052 to the power of 200 minus 1 all over 0.0052 times 1.0052 to the power of 200 is approximately equal to $84,424. Hence, N equals 200 is too big. 1. Ted's next guess is N equals 120. Show Ted's working for this guess, including the calculation and the conclusion. And 2. State a reasonable value of N for the next guess. Recall that N represents the number of months it takes to repay the loan. So the idea of part 3 is to find a value for N such that the value of this formula here is equivalent to the value of the loan itself, which is $70,000. So trying N equals 120, so substituting 120 for N in the formula, we have 680 times 1.0052 to the power of 120 minus 1 all over 0.0052 times 1.0052 to the power of 120, and that's approximately equal to $60,590.10, which is less than the loan amount of $70,000. Hence, N equals 120 is too small a value. So we need to try a value between N equals 120 and N equals 200. So for my next guess, I'm going to try N equals 150. So 680 times 1.0052 to the power of 150 minus 1 all over 0.0052 times 1.0052 to the power of 150 is approximately equal to $70,702.56, which is much closer to the value of the loan compared to the guesses of N equals 120 and N equals 200.